Assalamualaikum. In today's lecture of Computer Organization and Assembly Language, we are going to cover computer architecture, computer organization, components of a microcomputer system, instruction execution, instruction codes, programming languages, communication modes, and computer buses. So let's see what is meant by computer architecture. Computer architecture refers to the design and the basic structure of a computer system, which includes its hardware and their interconnections and the principles that guide their organization. It is those attributes of a system that have a direct impact on the logical execution of a program. It is concerned with the structure and the behavior of the computer system as seen by the user. So if we look at the term computer architecture itself, the architecture gives us a very familiar word known as architect, which we hire when designing our home structure. Our architect tells us where is going to be our room, where is going to be our living room, and what else. So basically, computer architecture refers to the computer designing. There are some must things which should be in the part of a computer architecture, as in without these there is going to be no computer architecture that is properly set. It is a combination of various components. For instance, you can say RAM, hard disk, buses, integrated circuit, ALU, processor, register, and whatnot. So all of this, how it connects with each other, that is what our computer architecture tells us. Let's look at what is a computer organization. Computer organization, it is a very self-explanatory word as it defines organization. That means it's talking about organizing things. It tells about the ways of the way the various components of a computer system are interconnected and how they are working, how they are performing those operational tasks, and how they are executing the programs. It talks about the physical components of a computer as well as the hardware components, how they operate. It sends our control signals and interfaces between the computer and the peripheral devices, the memory technology being used. And there are two types of computer system if we talk about. One is our general purpose, which we use on a daily basis, and the other one is our embedded systems. So embedded systems are the one that does a particular a specific task. For example, fridges, our microwave, they are responsible for only one task at a time. On the other hand, if we look at our general purpose computers, they do lots of multitask at a moment. So let's look at how those computer signals work inside the computer system. This is what our computer organization informs us about. So our memory, if it's our memory, here is our register, and let's say here is our ALU. So how the whole mechanism works is that memory sends instruction to the register stores it and sends it to ALU for operation, and ALU sends it back to register to copy it back and then eventually send it to the memory. So what is the role of control signals here? There is a dedicated hardware which manages control signals known as control unit, which is a part of CPU. So it informs the user that it informs the computer that when it guides the computer, it's a you can also say it's a supervisor of a computer that tells us when do you have to send those instructions, how are you going to send those instructions, and where are you going to store those instructions. These are the control signals managed inside the control unit. Let's look at the components of a microcomputer system. So microcomputer system, it's a term which is commonly being used, and it's something the students find it very difficult and confusing. It's nothing but a microprocessor as a CPU. Okay, microprocessor as a CPU. You can also write CPU here because this entire of it is a CPU, which we can call a microprocessor as well. So in the microcomputer, Instead of CPU, we use microprocessor, which is combined with our input and output devices and memory unit. So in this is very simple. We insert a task to a computer, and then ALU manages all the calculation tasks and the logical ones. Control unit manages all the signals, and then register array copies and stores the information for a while and then send it to the memory unit, and eventually we receive what we commanded the computer to do. Let's look at instruction execution and machine cycle. The process through which the processor controls the execution of instructions is referred as fetch, decode, execute cycle or the execution cycle. We have often heard about this term fetch, decode, execute cycle. We can also call it von Neumann architecture. It's a similar thing. Okay, von Neumann architecture. And basically what it does is fetch in simple terms means लाना, कोई भी चीज लेकर आना. So upon receiving data or the instruction, what processor does is processor fetches those instructions from the memory. There are memory and processor fetches those instructions from the memory. So how it works is memory sends the data on the data bus. It's our data bus. Okay, it's our data bus. It sends the instructions to the processor, our brain of the computer. Okay, processor, and then what processor does is it copies it. It copies the instructions and then paste it onto our register. I'm just going to use those key doodles so that you remember them as it is. So memory sends the instruction through data bus and sends it to the processor, and then processor copies it down and sends it to the register. This is how what happens in the fetch cycle. In only fetch. In decoding, what happens is that all the instruction that the memory stores and sends it to the register, finally, what it does is it actually processes it and tells us the calculations, basically does all the calculation and the instruction. So it decoding or identify the instructions, and eventually in the last step it shows us and executes the operation that has been formed. So this entire mechanism which goes on and on, that is called fetch, decode, execute cycle or von Neumann architecture. Let's look at instruction codes. What are instruction codes? Let's look over program. A program is nothing but a set of instructions that specify the operations, operands, and the sequence by which the processing has to occur. In our programming, what the computer does is it look at the operation that has been performed, and in a very sequence. It doesn't go like if this has been the task. It won't go like I'll do the one now and then I'll go do this one. It will do in a specified order. And then computer instruction is a binary code that specifies a sequence of micro operations of the computer, and instruction code is a group of bits that instruct the computer to perform a specific operation. So they are nothing but the bits that instruct the computer to execute a specific operation or function. Memory hierarchy. What is memory hierarchy? In the computer system design, it is an enhancement to organize the memory so that there is a minimized access time. And it was developed based on a program behavior known as locality of references. We are going to look into this diagram in detail, but first let's look at those types of memory hierarchy. There are two types of memory hierarchy, external and internal, which comprise, if we talk about external, there is magnetic disk, optical disk, magnetic tape, peripheral storage devices which are accessible by the processor via an input-output module. And about the internal memory, it includes all those main memory, cache memory, CPU registers that are directly accessible by the processor. This is our memory hierarchy chart, or you can say a pyramid or a triangle. Firstly, we have registers, which is stored in bytes. Then we have cache, or we can call SRAM as well. It is stored in KB or even MB as well. And then we have main memory, that is RAM or our dynamic RAM as well. Here we have our GBs, okay? And then we have flash disk. We are very used to using flash disk, USB and SSD. We can have GBs in here as well. And then in the traditional disk, we have magnetic disks, and we have even magnetic tape and hard disk. And we usually see hard disk of like 1 terabyte, 2 terabyte, and then we have finally the remote secondary storage internet. Alright, so firstly we have to look at the cost. If we look at the registers, they are not very expensive, but if we look at the magnetic tape or the hard disk, they are very expensive. So this is our most expensive way, and this is our least expensive. And if we talk about the speed, the fastest is the registers. Registers do their work in a very quick manner, so they are the fastest and they are the slowest. Don't mind my handwriting, I hope you understand. Okay, and about the access time for which this huge pyramid or memory hierarchy was formed, it increases as we go down the group or down the pyramid. So the access is basically that if there is something fast, then we are able to access it faster. And about the size, registers are smallest, and gradually if we go down, it increases the size. Okay, let's talk about the programming languages. We all know about multiple types of programming languages. There is low level language, medium level language, and high level language. In low level language, which is only understandable by the computer itself, that is binary code, machine language. And if we talk about medium level language, we have assembly language, which we will be looking into in more detail, and then C and C++. And lastly, we have high level language, that is Python, Java, Pascal, and other, etc. What is the difference between low level and high level language? Low level language is close to the computer, which is only understandable by the computer itself. Its processing time is very fast due to it being understandable by computer itself. For example, you know a person who knows Urdu as well. So you will be able to understand him more quickly. You won't have to process the same thing you don't have to process that in a long time, or you will be able to understand it very quickly. On the other hand, if I am speaking to you in English, you will be able to understand it, but you have to process it. You have to listen to it again. In a human, that happens as well. The things which we are familiar with, we are more likely to understand that. सिमिलरली अगर मैं आपके साथ अभी उर्दू में बात कर रही हूँ, तो अब आपको मेरी बात समझ ज़्यादा सही से आएगी कि मैं कह रही हूँ कि प्रोसेसिंग टाइम जो है वो फास्ट हो जाएगा लो लेवल लैंग्वेजेस में, क्योंकि वो कंप्यूटर अंडरस्टैंड करता है, और जैसे आप अंडरस्टैंड करते हो मेरी उर्दू को. और अगर मैं आपसे इंग्लिश में बात करूँ, then you won't be able to understand it much more faster as compared to Urdu. But I hope you will be able to understand. As high level language is close to the user, and you can see this is a program written in our high level language. And for low level language, we don't have to use any sort of translator, assembler, or compiler. But in high level language, we do need to use an assembler or our compiler or interpreter to translate and understand how the language works and how the instructions are going into the computer. LPS, the similar thing which we were talking about just now. Source code. For example, we have insert a program in high level language to a computer, and this is the entire process on how computer understands our code which has been written. So firstly, computer will take our HLL and send it to the interpreter. What is an interpreter? Interpreter is a line-by-line conversion of source code into the machine language. What interpreter does is it converts our code into machine language which is understood by machine, and it makes it a modified source program, or we can also call it pure HLL. Then the pure HLL has been formed, and after that, basically in this step, what interpreter is doing is it's basically removing all the access files and all the unnecessary macros identified. And in the pure HLL, it is compiling things. What does a compiler does? Compiler is whole source code is converted into machine language. In the interpreter, our interpreter goes line by line on the code, but in our compiler, it goes in one go. It goes through the entire code in one go. So when the pure HLL will be passed through the compiler, it will form a target assembly program. We'll end up with a assembly program, and then we will send it to the assembler. We are not going to do that. This is what happening inside the computer itself, and then assembler will convert it to a relocatable machine code. And after sending it from the linker or loader, what it will do is it will give the computer the target machine code which it was looking for. And after that, the computer will perform instructions, and then eventually it will go back and send the user the response. So this is how the language processing system inside the computer works. Let's look out more about the communication modes, or we can also say transmission modes. There are 3 different types of transmission modes: simplex, half duplex, and full duplex. So what is a communication mode? Communication mode is a way in which data is transmitted from one device to another. So in simplex data transmission, what happens is it's a unidirectional transfer of data, in which data transfers only in one direction. There is no receiving back. For example, we have multiple examples. We can say television. In television, what we do is we just watch things. We cannot send data back to the television. So it is one way transferring of data. That goes in the example of simplex data transmission. There are furthermore examples. For example, you can talk about the keyboard, OARD, keyboard. Okay. So in the keyboard, we are just inputting stuff. We cannot receive something back from the keyboard. And likewise with the monitor and even radio stations. In the radio stations, we cannot send stuff. We can only hear it. We can only get it once. And in the half duplex mode, it is bidirectional, but not completely. It sends the data and can also receive. It can send data and can also receive data as well, but there is a condition: not at the same time. It needs to take some pause or break in between. For example, you are using a walkie-talkie. What you are doing is your friend A is going to speak into the walkie. Okay, like that device, into that device, your friend A is going to speak, and then you are going to hear it only. The B is only going to hear it, and after B has heard what A has said, after that he can start recording, which will be sent to the A. And in the full duplex mode, it is a fully functional bidirectional, and in here we can even do it simultaneously. It's a very common example, just like we do every day, which is calling, right? So a little question from all of you guys. Make sure to answer it in the comments down below. Let me know. I am talking to you and teaching you about this course. What do you think? What sort of communication mode it is? Is it a simplex? Is it a half duplex or a full duplex? Let me know your answer in the comments below. Let's look at the computer buses, or our last topic of this lecture. Computer buses are nothing but the collection of wires. These are those electrical paths which exchanges data from one place to another, right? So as we saw our computer bus, so our computer bus does not look like this, but we will make it like this. Okay, so in our computer bus we have two different types of buses, not data bus, control bus, and address bus. These terms are very self-explanatory. Data bus takes our data, control bus gives control directions, and address bus takes our addresses. So data bus all can read and write, control bus can read and write and then send status and error messages, and address bus is a simplex duplex which sends our address. Our buses are almost like if we look at the highway, what highway does is that if what our highway does is that it connects two towns with each other. Similarly, a bus, it connects one device to another device like a highway. So this is our bus and this is our device 1, this is our device 2. So our bus is connecting both of them. There can be an internal bus and there can be an external bus as well. We have different types of buses which we just talked about: data bus, computer bus, and address bus, and they have particular tasks that they do. And similarly, we have seen that our control bus is bidirectional. It can go both ways. Our address bus is only one way, and our data bus only goes one way. Okay. A data bus also goes both ways because it gives, if it is taking the data from here, it can send it back to the here as well. Similarly, we have seen memory and CPU and input output devices in previously in our components of a microcomputer system, and I hope you did understand this. That's it for this lecture. I hope you did understand it. If there is any confusion or problems, let us know in the comments, and I hope you liked it. Thank you.